Good morning, everyone. Good morning. So, like we discussed yesterday, as we are going to start all over with this circuit. So this time around, we are going to make it two different outputs. For this one is just a 5 volt power supply. So now we want a power supply that will have two different outputs, which will be what? 5 volt and 12 volts. So I'm going to start all over again. I'm coming, actually, the software can also do everything by itself. It can reach the company by itself, right? Okay, please let us see how you do that one. I want to do that one. You still teach us that one. We're not going to do hard again. Nah, I'm not going to do hard again. So now, for us to design a power supply, the first component we need is to get our what? Transformer. Is to get our what? Transformer. For a power supply, how can you protect a power supply from overvoltage or current? How can you detect a power supply? You know, there are two different things that can damage a device. Is either high current or what? Over voltage. Then when it comes to current, it is not maybe a current is coming from the source and the current runs through the what? Power supply circuit. It is maybe a fault, a short circuit fault inside the power supply that can cause what? High current to flow through the what? Power supply. So how can someone protect a power supply from short circuit and over voltage? Resistor and what? And what else again? Ah, what do you say? No. Where's resistor will work for what? Is it for current or voltage? Voltage. Yeah. What about for current? Fuse. You can use a resistor fuse. And if you don't use resistor fuse, what other components can you use? No. So you want to put a circuit breaker inside your power supply design. There's a component we call PTC. You can make use of what? PTC. So here, I want to use a transformer that has what? That has two different what? That has two secondary. Maybe you can search for this. Maybe you see it. BV020. Come to like filter. Click what? All libraries. Then type it here. Or if possible, if you can search for it under by yourself.
So what's the number?
BV020. It's not under this. Maybe just have that. No, 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 not like pattern. The pattern is the pattern. The pattern is not right. The pattern. When you click on the graph pattern, take it back. Press escape. Look at the pattern. No, don't argue. Scroll on this. When you go to the pattern.
Okay,
What's the number? You can try Amon 164.
I think 161 60.
What are the patterns? Look at the pattern you are using. Look at the pattern. Do you know what's the meaning of this dot? In any component, if you see this dot, what does it mean?
That is
In one. Okay, wait. We brought it. What you're trying to get is here. You have something like this. First.
it's talking about the pattern. That will be pattern of pattern.
Which pattern?
The lower one. The lower pattern.
Okay, okay.
It's not second.
So it's not system. Or okay, go for something like this.
Okay.
Or
Yeah, I found it, but the pattern is
I'm coming.
this one there.
You know that if you are using this type, you are tying this together. So this type or this type, graphical symbol. Then the pattern, then the pattern should be something like this.
No, before you select, you see the pattern.
1, 2, 3, 4. 1, 2, 3, 4. Or 1, 1, 2, 3. What is going on there? Any one of these. Let the graphical symbol should be something like this. Why the pattern should be
This or
any of
this.
these two. So search for any of these.
What of the one that has that pattern, but without where the first pin is, without assigning the first pin, symbol for that one there.
So I think that. They have to assign. One of those two before. Yeah, this one will work. You can just read it. Yes, it will work. Huh? Yes, yes, you can use it. You can use it. You know, what we are doing now is just for the sake of this class. If you are to have your own design, the dimension of this must be the same thing with your what? Your transformer you are using. The dimension for the pattern must be the same thing.
The physical size of the person.
Yes. It's can no just so that's the we have the what? Transformer. This is the transformer. And let's go for the source. Okay, symbol. Go under symbol, you see source. Space bar is for you to what? Rotate. This is the what? Source. And you can just ignore that you are still going to create a pattern for it. What's the full meaning of BOM? Full meaning of BOM. BOM.
BOM.
Yes. What about BOQ?
BOQ. That's the bill of quantity. That's a component.
You've gotten that. So what about for BOM?
What is bill of quantity?
Bill of material.
Okay, bill of material.
So the list of any components on your PCB is classified as what? We call it what? Bill of material.
Bill of material, not bill of
So this software can also do it automatically by itself.
wow. Sure.
Automatic, just tell it to extract it for you. Then the list.
Send to us, so that we should be very interested. Show us the circuit that implemented PCB there.
Yeah, it doesn't have patterns. You know, like I was, if you can remember, hello, yes. Then if you can remember the AC source, this is what I was, this is how it looks like. It is something like this. You have something like this on the board. And that's the source. It is the dimension of this you will use to create the pattern. You now attach that pattern to that AC source. Because we don't have a defined pattern for now to use. Yes. You can just create two O's representing live and neutral for that what. Then attach it to that source to represent that okay, 240 volts is coming to that what to that point.
Okay, I see. Then it will give you special software.
Why?
What will it make? Yes.
This time I'm not rushing at all.
Okay. I know what is done, but they actually said you can use anyone. But if I'm using this one, I'll find it.
I get it.
Okay.
What instructors are? Instructors. I saw a transformer. But this what's called pattern. It's like upside down. There are four others and two zeros. Is it the same?
Which one?
This pattern by the right. This you draw by the right.
The top or the down.
Okay,
Okay, the numbering abi.
no, I mean the way the beam is arranged. It seems to be vertical, not horizontal, not vertical like this.
You can rotate it now.
Okay, so it's still the same. I can use it.
You can rotate it.
You can rotate the pattern.
You can rotate.
I didn't know since I saw that one calling for
So the next thing after transformer, what's the function of this transformer?
which time?
Is to what? Step down the voltage. So now here our power supply value is what? 240. 240 volts. And for this transformer itself now, since our power supply will be what? 5 volt and what? 5 volt and 12 volt. Okay. That means our transformer will be 15 volt transformer. Yes, 15 volt transformer.
Our power supply is 247.
Yes. 15 volt transformer. That means
Sorry, sir. Must we always specify because the symbol is already AC? I was going to ask that question. That using this symbol shows that it's AC input. So why specifying the value? Must we always write 240 volt AC or just write 240 volt?
there are some countries that make use of one thing.
No, I know. I mean, the adding the AC. adding the AC. Can we just write 240 or 110 volts and not add AC?
Yes, yes.
Okay. Maybe I've done a lot of simulation, so you know the setting of it.
So that's it. And for this one now,
Please, before the source, after putting the 240 then
The other details are not so important.
it's not showing. It's password.
Why is not showing? If you click on it, you are typing it.
After typing it,
It's showing. If you are typing it, it should.
you have to type under value. If it is not showing, come and see. Just come to properties. Yeah, where's path markings? Where are these path markings?
Okay, you have to show value.
If you want it to, here you can set it.
Wow.
If you want it to show the ref desk, value, name, but all those information are too much. It will be too much for you to display it. So once you just click on the company, any information you need, you can see it here. If there's any additional information, once you click here, it will tell you. So the next component is the what? Bridge rectifier.
Oh, sure. The device. Okay. These are the device. Let's go to the. No, I told you that the guy should be in the.
I think that should be under property. Where's property? Down.
Okay, I get what you're saying now.
You can make use of any of all these ones. You can make use of this one. This one is common in generators. This type. Anyone who has worked on the generator before, you should see this type in generators.
Thank you.
This one's are SMD. How do I? So let me just click one.
So what do we do next? Okay. I'm going to select the book. From here again.
That book is where
What did we do?
You can search for it now.
let's see the pattern.
Just DB deep is a this thing. The standard this thing. Yes. Direct bridge DIP. You see it. Just type it. This. Search for it.
Using filter.
Yes. How many percentages? Zero. Okay, okay, okay. I'm using pattern for you. You're on schematic, sorry. But don't you have direct bridge on your own system under
Yeah,
components?
that's wires.
Okay, we have there. There.
Any part you can make use of any pattern. It depends on the type of diode you're using. It's not compulsory you select the same. Yeah. So you have different pattern. Just make sure it's there. Anyone can work. This can work. This can work. This can work. Any of it. This type is common in generator. This and this one too. This one too. It's common in generator. If you check anyone, just select any group diode. So after rectification is what? Filtering. So if you have capacitor too, under discrete capacitor. And look at the pattern of the capacitor you're picking should be the big one. Electrolytic capacitor. That's what is used for filtering after rectification. So this one is big. It's there. Here search for cap 300. You see it. Just search for cap 300. Filter cap 300. You see it. It's there. It's different. You have a higher version. You see.
Our
Filter. Abi? God. Which is it? Press cap 300. You see it. You see it.
then this workspace, I'm having problem moving navigating.
This is how you do it. If you want to move around, right click, press and hold.
Okay.
Then you can
Okay.
move around. Then you can use all these points to move this one.
Okay.
So now we have our capacitor for filtering. Then the next thing is for us to what? Voltage regulator. Now we are going to make use of what? Two different voltage regulator. One will be what? 12 volts and one will be what? 5 volts. So you can filter that too. Right? LM what?
And then 78.
70 to 5. It's better you just type 70 to 5.
Not problem.
That's bring out 7805. Can you see? Drop it. Do you know that presently what we are doing presently is just what? It's just graphical symbol. Hello? Do you get me? It's just what? Graphical symbol representing a component on the board. Are you with me? So now look at this guy now. 7805 and 7812. The normal one you buy in market, they have the same pattern. Do you know that? 7805, 7809, 7812, they have the same pattern.
My, my own does not have discrete, or that the proper does not discrete. If I say they use higher version.
I search for it, 7805, that I fit that. That's what I did. Hello? Do you get what I'm trying to say? There's something I want to do. Look at this guy now. It is what? 7805, right? Look at the attached pattern. This thing is too slow. It's not showing it. Look at the pattern. This is the pattern. The number of the pattern is what? TO220. So if my 7805 and 7812, if they are the same, if they have the same pattern, I can just what? Copy this one and paste. The only thing I need to do is what? Change this one to what? You understand me now? So I have what? 7812, then I have what? Fine.
What's the component is?
Has the same pattern because they have the same pattern. And that
It's because you are used to it. That's why you knew 17012 and 17025 has the same pattern. But when one does not do that, they have the same pattern.
before you start your schematic, you have known the components you want to use. First thing, you can do schematic before you even sort out component. It is when you start, before you convert to PCB, you now what? Source for components. After you now source for components, you now start attaching the pattern to your existing schematic. You might have simulated the schematic on Proteus without having component already. So after you simulate it and see that okay, this circuit is working fine on Proteus, that's when you now start finding, components have equivalent now. If you go to market, if you tell them, I need this transistor, they will tell you, we don't have this, but we have the what? Equivalent that can do the same work that
My village is where
the village people say.
yeah, it's not far. How much is this away?
Research. That
Our own is not
Eh?
our own is not just something. PCB at the back.
But it gives you that pattern. Yeah.
Okay. I was searching for LM, I didn't know it's only L now.
Just put 7805, you see it.
No, I was searching for LM.
These are all don't get 7325.
Our own.
It's still the same. As long as you have that pattern and the graphical symbol. This is the graphical symbol for linear voltage regulator. We have adjustable voltage regulator too. We have adjustable. No, for now we are using this thing now. Look, the pattern on this is T0220. Like this one, I've seen this one before. 7825, but it is SMD. SMD 225. I think this one very well. These are the other one you are seeing.
Yes.
They have the same pattern. T0 2020, but the number is just based on like manufacturer. It's not SMD.
When you use the same parts, are we going to call the part name for each of them to part one, part two?
I don't understand.
No, please delete one of those YouTube. Please delete
This is the YouTube.
I want this just the properties to come.
Look at it, I've changed it to
Okay,
17.
part name, part name.
Part name.
Yeah, part one, part one.
No, 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 no. You don't have anything to do
This
with
one is
that.
part two.
You don't have anything to do with that.
Okay. So once the part names are different, you're fine.
No, no.
they are the same.
Just
When
ignore
the names
part.
are names,
The what?
the names you can.
You the rep desks are not the same now. This one is U1. This one is U2.
Okay, then why did you change the name to 7812? Can you read that well?
This one is 5 volt regulator, 12 volt regulator.
Okay.
So for the 5 volt regulator, what will be the value? 5 volts.
5 volts. It's 5 volts.
Then for this is what? 12 volt. So now we have two different voltage regulator. So the next thing is for us to what? Do you know that I was saying something? Do you know that we have adjustable voltage regulator too?
Yes.
Yes, adjustable, whereby the resistor and capacitor value around it will determine the what? The voltage output. So if you check the data sheet, you will see, okay, if you want 3.3 voltage output, these are the resistor value and capacitor value or inductor value you should what? Put for you to achieve, for you to get what? Maybe 3.3 volts, maybe 5 volts, maybe 4.9 volts or 4.7 volts or 5 volts or 9 volts. So even while you are doing that self, you can even make use of POT for adjustable one, whereby when you rotate the POT, you have different what? Voltage outputs. So now the next thing for us is to get filtering capacitor for this, for the two voltage outputs. This capacitor value should be what? 1000 UF 25 volts.
Is it just UF? There's no.
That's it now. You miss micro.
There's no green micro.
There's no the correct mu. There's no letter mu for it.
Letter what? I don't understand. Okay, the symbol. That's how you just make use of small letter U.
The system recognizes it.
Which system?
Okay, you don't have to recognize it since it's not simulated.
So
I get it. Since it's not simulated.
so that's it.
Okay.
So after this, we need the what?
You need the capacitor.
Filtering capacitor.
Go back to capacitor.
Capacitor. I know type of capacitor it is.
So you cannot use similar capacitor. You polarize the capacitor.
Small capacitor.
Cap 100.
Capacitor, titanium, ceramic, aluminum, iron.
The fact that somebody
one? The pattern. Look at the pattern. Pattern cap 100 is the size of the diameter of the capacitor.
But for the second one, I did not have the same pattern.
They have the same pattern. And so I use the same thing.
Even with what you say, that if you just copy it, just like duplicating it.
Yes, that's what I did.
Okay, but this 1,000 has a different amount to what this was.
Yes, it's big one now. You know, 1,000 UF is big now. You see, that one is like 250. The radius. See, okay, it's 300 itself. Look at these ones. They are small ones. 100. 100. And they have come with components, but we are not yet to do electronics. That's why. Eh?
So what is the value of C2 at 250?
No?
Please, what's the value of the second two capacitor? Are they 100 and 400? I'm just asking.
No. Let's use 10. 16 volts. 16 volts 10 UF.
Capacitor, capacitor, something like this. This capacitor.
This circuit you are doing, if you get all the components and you are ready to work on, no, all these components, this design you are doing,
It's a working circuit.
yes, it's a working circuit.
Is the pattern that one real?
Yeah, yes. RP and what? AP. Sometimes you see the shape. Let me show you. You see it now. Look at it. Look at the pattern.
Okay.
Which one do you want to check? Okay, this 1,000. RP and what?
I just cap.
Look at it.
Okay, it's cap is cute.
So this one is round. See, that R means what? Round.
Okay. Round products. I'll be around pattern. Anyway.
Okay, Sunday for Sami. Mélòó ni méjì àgbà? So drop it, snap paper and see paper can security by people.
100.
These are the type of capacitor we are electrolytic. understand? This example of the type of capacitor we are using. Is how it looks like. So after that, we are going to have our output, terminal output for the what? Output voltage from each regulator.
The C3 you are not written the voltage.
Which one? C3. Okay. Then you have
First one is also 16 volts.
yes. The only thing there is that the capacitor value must be higher than the value getting across it. The capacitor voltage, the voltage must be higher than the value of the voltage getting to that point. So if you're having 12 volts coming out, you should have a higher capacitor value across that point. Yes. So that if the capacitor voltage value is lower, it will just what? Explode. Don't waste time.
Sorry, please. As an assignment, I have not seen it on the board.
Sometimes it's not compulsory. For me now, I don't really like all this value because it disturbs my routing. If you want it to show, you can just come here. Properties. You have to see them here. Parameters. Show height, everything. So,
The value I think is the common average.
But the showing of the values, I think is not useful. That's why I put it there. Now select the value. Not showing the value is disturbing it. Select values. So it's showing what is it not putting in other needs? Suppose you're doing that. Please do this so that I'm not going to show you that. Do you understand?
All of them.
Who have seen this application before? Yes, I do. This application. If you enter the value, you
Just change it. Wow. Yeah, just give it a Oh, so it's free, right?
yeah.
Okay, is it online?
No.
Please.
It's from him.
Please could you copy even if it's lower version for us?
It's 5 band. So
It's a very beautiful something.
you can see unit conversion.
Ah, wow.
Convert.
Oh, wow.
Everything.
Ah, wow.
So you can go to capacitor too.
Can we have the
If there's a flash, I'll show it.
Oh, there's a flash.
You're very
beautiful.
Alpha. Chronometer.
Doctor, say.
Chronometer.
Flash.
No, I don't want virus. One flash.
What do you mean? It's only one. This is vertical flash. Are you aware of vertical? Are you aware of vertical? This is from vertical. It means Faculty of Engineering and Technology International Conference, hosted by Illinois. You understand? And that flash is
Sorry? So you can do capacitor follow too. No, you have
how you want to take this?
you have you can do capacitance follow code, series connection, everything is there. Common life is there. Charge and energy in the capacitor.
Wow. You can do a lot of calculation.
Enter the voltage, enter the everything is calculated. Then 5 timer calculator, house color calculator, reactance calculator, everything, power. Power calculate everything.
Okay. Wow, this is beautiful. This is beautiful. In fact, this should give someone a very good guide in knowing what
modeling
the
the maybe any of the components. I want now this is advanced this is where you have to go.
Yes, no, maybe you did it yesterday now. Maybe you
So I made for this app.
No, this app is just to give you an idea of,
Just to choose students on
not only color follow.
Let me stop my office and then I will now see what is possible.
Even frequency calculator is there, reactance calculator. Even this 5 timer. If you are using 5 timer and you want to calculate or you want to use it as stable mode or monostable mode or bistable mode, it will tell you the value of all the components to be attached.
Wow, so this is beautiful.
So if you enter the value, you get everything. No, 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 no. It's just for electronic thing for calculation to get the actual It's an application. It's not. Hello? Okay. My joke. So you can even select the color. You understand? Select the color. Don't put that. Click on the color. Maybe you have a response and you just see the color. Click on the color. Right click on the color.
Okay.
On each.
Okay. And if I change it.
Click on it. Bring the back.
Okay. So it's not a system to know the value. Instead of your hand, I can just come here and match the color.
It is 4 band, it is 5 band. I'm not rushing though. By the time I request for your laptop, you see what you've done. Ask Afa, he knows me very well.
And where you are there? What's going on? Sorry. Which village are you? No wonder. Your own part. They follow me. Me, I'm where you are. What do you want us to do? This is somebody that got 45 minutes.
So now the next thing is for us to get our. I think during your uni you did this power supply, right?
Yes.
And it worked.
Yes.
But before they got it that very small. Component arrangement. If I want to do it for you, after I did this one for you, I'll make sure you use single die, 4 single die for the distance.
But this software, you have to remember
It has a lot of things in it.
a lot. This is good. Please wait my lunch. Okay.
Do you guys need the software? Do you need this?
You always
So, well, okay, can you get me another flash?
who needs the electronic assistance? They all, you all need. Please just know the person you are giving it to. Now you like big man, they laugh and grab.
Another thing is this. Even though you don't know, even though you just see a resistor and you just see the color, you don't know the value, just click on the color bar here. Put the color of what you see. It will show you the value. It will just show you the value. It is 5 band, come to 5 band. Just click, select, put the color, you get the value.
The flash has traveled. Okay. Now you give me like you way your system know what's happening. I don't know whether that's flash.
What's assisted listening? Specification. Eh? What?
Okay, this question.
Yes.
Um,
Processor and the RAM.
the RAM is 16 gig.
So why is it RAM?
It's not ranking.
16
It's
gig.
doing updates.
Ah.
Okay. 16 gig. Wow.
It's that kind of bit.
It's doing
The
updates.
laptop is big. Hey, Alpha. Auntie. The laptop is for serious. You see,
He had it, so I still want to find
So now the next thing is for us to what? Outputs. Because at this point we already have our what? Voltage output here. We have our what? Voltage output here. So the connection point for our output. So let's just go and select. This one is no. Just go to connector. Connector headers. You have the higher button now. Connector headers. Just go to connector headers. Or type HDR minus 1 times 2. So connector header for this one output and for this output. Then we are adding an indicator, right?
so we should search for what?
HDR.
Header.
Dash. No. Use this name.
644. 644.
So you should use 6
You have it is there. Con is there, sir.
I saw many forms.
That's what
That's the problem. You don't have only one form.
No, not only one con. Look at it. Con this up, con edge card, con flash flexible.
You only simple or only current header, current but complex. That's it. Complexity for this place. I have more. Come back. I have more. That's the only problem.
Where's the first one? Let me see. You have click on it. Let me see what. Let me see. It's not this one. It's not this one. Let me see that power. Try it. It's not from this side. This one is connectors. It's not from this side. It's like what's happening. You have more than this.
There's no point. Why do I have one?
You see it. Go scroll down. It's not on this one. Scroll. That this one's like that.
What is yours? Why did they open this?
The one I'm using here. Is it one?
Okay, something like that. Okay, this one.
No.
Okay.
TBT or TB.
Contibi header.
Contibi
header. So search on that.
Contibi headers.
Yeah, just so I'm not sure which one is more.
How many do you need? Two.
I will say that because
How does it work?
Pattern.
What pattern is it?
But it's 190. Who is with the flash, please? Are we done now?
so serious employee.
Who is with the flash? Okay, you're with it.
Engineer. Distractions. Because when you do this, when you crash, of everything you don't touch, you may realize the program and no longer pay attention and you'll be like, we're going to watch it after. But that was yesterday has been on my YouTube now. So I was like, only every so in case anyone doesn't understand that, so now it's in the day you can hear was 4 hours. So but
Actually, I want to sing.
yeah?
Actually, I want to sing. Yeah.
Yes. So but after 6 years and I this video then, so yes. My own pattern is
So I'm trying to verify something I just did now. So I've been able to download the 3D model. What's the flash? The 3D model of all the components.
Okay.
So when you are viewing it now, if you view the real
3D model of all the components.
yes.
Oh, very good.
For example, now just look at this component I placed here. By the time you say you want to view it, assuming we are through with it.
Okay.
For example, look at the little component I picked now. You can see the 3D model.
Okay. How you take copy?
Don't worry, we get it.
Wow, this is beautiful. This is beautiful.
The flash drive so that it takes time. So
Okay.
yeah.
Wow, this is beautiful. The 3D model they showed us. They showed all of us together. I don't have any advantage of us when you start lecturing.
But you are still going to.
I always said I'm looking at the bottom. I'm not looking at the
You want to? I'll give it to you. There's a flash. So stopping. It will take time. So
okay.
so now the next thing, are we okay? Let's put an indicator, right? So for us to put an indicator, we need what? Lead and what? A resistor. Just one resistor is okay. It's not that general. No? Yeah, it's not that general. Yeah, I don't have general yet.
Yeah.
It's not that general. The one I'm using on my PC is even higher than this. So, so I want to start doing the word connection. Let's assign this, let's attach a pattern to this one. You can see it. Attach pattern. Just like a two-wire connection.
When did you choose the pattern? Okay.
I just had like an header connection. Just to
Hello. I don't see this one in my name.
this script. I use general. My own, your version is higher than my own version.
I have from the top.
I'm serious now. This one is. I don't use laptop. I told you.
You make it continue. No, why do you
Go to general now. Okay, continue. You can. Okay, this one is under pattern. You have to search for it. So look at it now.
I won't see there is just 3 or 4.
No, it's plenty of. It's more than this.
Yeah, it's minimal.
TP.
No,
CTB. That's in my head.
Use HDR. Start for HDR. Aircraft.
yeah, like in
No general name.
okay.
My own.
HDR now. Search for HDR. It's there.
Under
Your library is more than this. Like this and
Yeah.
That's
No, I
Ajam
can't
more.
find general name. You can't find
I've known and I've upgraded. I'll upgrade it. I don't really use this. I really use this when I go out.
So when we're done now, just
No, hold on. Are you with me? Look at it now. We have to assign this pin. That okay, oh, this pin is representing this. You can see. Then this one is representing what? That was the error it was showing yesterday. So this pin is representing our what? Live and neutral.
After that, now,
Click on what?
okay.
Okay.
Because you have the patterns up there.
So now you can start our what?
One is attached with. Can we see it?
Then
No, just do it anyhow. It's live and neutral. Choose anyone for your.
Attach pattern.
so before connecting, I
You
want
come here, look at, let me repeat it again. Click on it. Attach what? Pattern. The system is busy copying that thing. Okay, this is it.
you build attached pattern. So we can attach.
Or which one? Or use HDR. You see it.
HDR.
Just click on HDR.
Go to general there. General up there. How do you know it's successfully done?
There's no general.
Okay, general.
Just click on
Just
HDR.
click on anyone there. That's it. Click on anyone. Just click on anyone. Anyone. Click on anyone. Press E. General. Take it to general. That's general. Come down. Search for HDR. Click on it. Click on that general first. Click on it. Okay. Now come down. Click on anyone. Yes. Press H. Click on anyone. Press H. You see HDR. Scroll down. And select HDR. HDR 1 by 2. Then connect your pin. Because it says anything can go to any of the slots. Hold that AC one, drag it in. You are close to it. What did they have?
So I want to start my wire connection.
How do you know it's perfectly done? After that, is it going to
Yes. Look at it.
okay.
It's because look at this. What's there? Look at this.
Well, I go.
Rattle line. That rattle line. That line is because it's hidden.
Okay, if it's not, if it's hidden, it's beautiful. Yeah.
You see it.
Yeah.
If I want to cancel the ratchet,
You can repick it. Use it now. You can cancel it. Attach pattern. Disconnect.
Okay. Unless I think I can connect.
Disconnect. Nothing there again. So I can connect this to this as one. Then connect this to this as what? Two.
I want to come before one. I always call it.
Anyone. Is AC.
Is
Is AC.
So do you advise that we attach patterns for each component before we do?
No, but this AC source now, we are trying to let you know that this connection point is AC source.
I know.
You know, when it comes to schematic diagram, as an engineer, you should understand that, oh, this point, what is coming there is AC,
Yes.
due to that what graphical symbol. If you do not use that graphical symbol, we can just use, for example, now, if I just pick, let me say, if I just pick this now, I'm coming. If I pick this like this, for example, if I do like this and I delete this and I pick this, Now take this. What is this? It's a connection point, 2 point connection. But you would, looking at the graphical symbol as an engineer, you won't know that what is the type of voltage.
Voltage coming, you will know.
You won't know. So instead of using this, you know, now this one and this have this, they have the same pattern. They have the same pattern, no? But using the right graphical symbol will help you to interpret the circuit. Okay, what is getting to this place is what? It's an AC 240 volts. So now we can start our wire connection. I don't think I need to wait for anybody on this wire connection.
Wait, why are you going to do that?
Although you said you are not.
You said you are not in a rush.
Wire connection, no? Oh, yeah, I'm waiting. So now we've connected our what? The connection point from the AC to the what? To the input of the transformer, which is the what? Primary side of the what? Transformer. So if you had to name this, we name this one what? Next name is what? Live. Then you can use L. You right click. Next name. Do you understand? Or you can click on it like this. It will appear here. Then double click here. Anyhow, you can come here like this. Look at it. I'll show it. Net name. Click on it and type what? Live or L is the same thing. If it is, it's live, Abby. Costume.
Okay, we should call that one.
Yes.
Because there are so many lights.
You see what I'm doing? Do you see what I did? I changed it to red. Yes, but you don't need to change it to just leave it at yellow.
Don't change, don't bother changing. Don't bother changing.
Just leave it. You can even come to property and do anything you want to do. But it's better you make it yellow.
So what did you need the other?
It should be neutral now.
Oh, okay. One is neutral.
You can put N or neutral, so anyhow you want it. You are not rushing this time around. You are going to do your own. No? The combination of both surface mount and through will be your own assignment.
The what?
Eh?
What's our assignment?
The combination of SMD and through will be the one I will give you.
But you will do,
I'll give you the schematic.
You will do through who?
No, this time around it will be combination of through hole component and SMD component. Press Ctrl S or else it will disappear.
Oh, you know the CSP? What do you know the
Okay, next up.
Sorry, you have money.
Okay.
Buy 60 gigs.
So take. You see 3D model deep trace. Install it so that your design will come out in 3D model. Yes, no, you can collect it.
We are They will graduate. They will not kill themselves. They will graduate. Let me call that back. Okay, sir. All right. They will graduate. They will not graduate.
So one good thing about the 3D model is that if you have the 3D model, you can extract what we call the step file. So that step file you can give it to those who do the enclosure for you.
He's saving his D.DCH.
The step what?
To save the extension DCH
For which one?
for this thing.
Yes, schematic. Yes, yes. This is.
Because I just used to save this.
Yes, what's that?
If you have another flash drive for the 3D model,
Honestly. Yes, yes, yes. Okay, we just need to restore this to
yes, complete. It's not. So can I continue? Okay, now this is our what? Oh, oh. we need two rectifier. But I don't think it depends. Looking at it, when it comes to PCB power supply design, what makes the voltage regulator get hotter? What do you think makes it get hotter sometimes? Yes, hot. Why your power supply is in use? What? No, maybe at normal
At normal operating voltage.
operating voltage.
Maybe it is overloaded.
Not overloaded. Not ripple sometimes. Sometimes it's if it has higher input voltage.
And that is not the operating voltage. That
No,
is
if you have the higher the voltage input, the more it tries to
get heated.
it stress the voltage regulator is stepping down that higher voltage because that voltage difference affects this it. If you have an input voltage, let me explain to you. It's a calculation for 7805 can take as much as 32 volts. 7805 maximum input voltage is 32 volts. 32 volts max in for the voltage. But look at it now.
Which component are you now?
7805. Okay. That's the last one. Check the data sheet. Okay. So now if you have 35, if you have that 32 going straight into it, 32 and current of how many current of maybe 0.5 amps is running through it. 32, right? And your output voltage is what? 5. 32 minus 5. 27. 27 multiplied by 0.5. That's the heat. That's the heat this guy will be dissipating. But if you have a lower voltage getting to like 12 volts at the input, 12 volts minus what? 5. 7. So 7 multiplied by that is 0.5. So that's what? So the higher voltage at the input, the more you are stressing that voltage regulator to what? Step down. So it's even good to get like it's better you have maybe like +3. You get me now? Yes. +3 of the expected voltage to go to the input. Okay. So now let us reason how we should do our connection here now.
Seriously, for the first time I'm seeing an electrical
You are seeing exactly what?
You see those neutrons.
Yes, I'm seeing
They are
electrons.
flowing.
Okay. So now let's say we can use 2 diodes, but what should be our transformer? Should our transformer be for each side? What do you suggest? Okay, we have 2 secondary. So what should be the? So should one be 12? 2 for what?
2 diodes.
No, I'm no. Let's discuss about the transformer first.
One should go for the 5 volt, one should go for the 12 volt.
What should be the voltage output for the one for 5 volts, what should be?
8 volts.
No, there's not. They don't really want 8 volts.
That's 6, 9, 12.
Uh-huh. 6, 9, 12, 15.
Yeah, 6, 9, 12.
And that one should be 9.
6, 9, 12, 15. So that means we should have one as what?
9.
9 volts. That's literally 9 volts. The one I've seen before is 15, 12.
Okay.
But all these ones I'm saying is based on our request.
If you
Like for our own, most of our products, most of like things like our transformer, relay, shunt, current transformer, all those things. If you are buying them in bulk, thousands, not 1,000,
request,
you will give them your specification and they will design it based on your what specification. So this transformer we are discussing now is like maybe we are sitting down that we want to design. So we have so we are looking at okay, how can we design a transformer that will limit the what heat dissipated by the what voltage regulator that won't stress the voltage regulator.
okay.
Then you consider cost too.
Let's just do the off.
So let's go for what? Uh, 15, 12.
12, 15 is still okay.
12, 15. Let's go for
The
12.
one that is available in the market.
It's 12, 15.
12, 15.
I've not seen that one. I don't really buy from the local market.
Because you have to look at the possibility of the off the shelf. The one available.
If you want to look at the one available, that means it should be 12, 12. Then that means our voltage output should be maybe one should be 5, one should be 9.
Okay, you can do that.
It depends. You can still use 12.
To go and be at putting 12.
You can still use 12. You can use 12.
The reason is that if you use 12, by the time you put the filter capacitor,
It will rise
right, the
to like
value will rise,
16
right, to around 16, then you
upwards.
can put the regulator.
Okay, so we can do 12, 12.
You can do 12, 12. It will rise. After that, once you put the this thing, bridge diode, the voltage will be okay. You will see the voltage. But once you put the capacitor, it will rise.
Okay,
It will rise. Sure.
okay.
It can even rise up to 20. So now let's use what? 12, 12. 12, 12. Different what? H bridge. So just press Ctrl C, Ctrl V. Ctrl C, Ctrl V. So now this go for this. Why this will go for what? This. This go for this. Why this go for what? This. So then look at the way you can arrange it that it will make sense. The arrangement. Let there be heart. There's heart design. Let's get it practical. I hope you know what I'm trying to do. Yes, you ask. Make sure you don't just design blue.
The other one to get out.
I think it's fine like this. It depends on how you want to arrange it. That means we have two different switching capacitor. Control C, Control V. Right. Ground should always face down. Voltage up. Hope I'm not so fast. I will stop when I connect the capacitor to error. Where? What happened to it?
Connected is not it.
Ah, mistake, Charlie. Okay. This.
You have to move it down.
Okay. Just a minute. Huh?
Sorry, if I select a line and I want to adjust it, I need to press something else.
You want to adjust?
Yeah, the line.
Okay, maybe the way you are placed,
Yeah.
actually, sometimes I'll just place it if you automatically. But if you are trying to move your mouse and it's not automatically showing this
Yeah.
arrow, you click on here. Click here.
Okay.
This one is pointer
Okay.
to move the component. You understand? This one is to draw the wire. Right? This one is to what? Move.
If we want to like this that connection point, like where we connected the capacitor CY, for instance.
Okay.
If you look at the terminal coming from the other side of the rectifier, it's process appear to cross a line.
Yes.
Instead of circuit format, we like to do something like this.
No. Those design rules, those are old design rules. They don't make it okay. Yes. They don't use them again. Assuming if there's a connection here between these two lines, you see a point. Since there's no point there, there's no connection.
How much is it?
Unlike before, you just see that the thing will just form one something like C. Like C, yeah. Another flash. Another flash for the 3D model so that you can view your design on 3D. Flash.
Another thing. Okay, another flash. Okay. Why you say nine actually? When is our next meeting? I want to move the negative. When is next meeting? Celebration when? Yes, I like it. I want the executive and the rest of it. But they talk about that. What it is, I see it. That's it. That's something.
Can I continue?
What did I say? Oh, okay. I'll put the national information.
So these are our what? 5 volts, 12 volts. Connected. Connected. Connected.
Groups actually one that comes with one. You see it open before. Have you opened it? You see group 3D model. Yeah.
No installing on the file. Copy it to your system before you.
What about for Mac? Are we going to get it?
It's on the website. Yeah? Yes, now. Let me show you now. Come.
Take time. The last five.
Until I like good space.
Look at it. Can you see?
Yes.
For Mac alone, that's it.
Okay.
You can see if they've increased the distance. 300 pins.
Okay, which one am I to download?
Mac now, I'm telling you for those of you that are not no, if you don't buy this thing, you'll be limited to that.
It's not free what you give us. Give us five.
That's it now.
You give us five.
Wait, I thought the one we have is for life.
But it's 30
Yes.
days.
It's not 30 days. That one is not 30 days.
Okay, the one you give us is not 30 days.
That you mean it. So that not when we dispatch.
It's not 30 days now.
Okay, I downloaded one yesterday. That's what I'm using.
Maybe it's
Which one? No, it's working on your system now, right? No, what you want to download is 3D model.
Okay,
Let me search for it for you.
The one you download that site, is it 3D photo?
No, I just downloaded it.
See my email.
Look at it here. Can you see it?
Oh yeah. Okay. 1.6.
Yes, now. Even the one I gave you self is 1 point. It's not up to 1.5. The latest one we have is 1.5.
Wow. But it's not free.
It's free.
You know to say salvation of
Anything that is not invented by some maybe US or Chinese. I think this is Ukraine software.
Yeah, free. That's one big thing. Social and
yes and Chinese and the like of
This is the first of doing Russia and free correct.
It's a Ukrainian software. So can we continue?
No, sir.
Time is going on.
I like the way I think small.
Huh? Let me see. The what? Increase it now, the percentage. Press plus or minus. It's plus or minus not working for it. Okay. Vertical flash. Look for no further. No,
No, not mine.
this is ready.
Thank you. Where's my own? Dr. Kwe, I still with my place. You don't copy and paste. There's one here. Okay, there's one there. Okay. Electrical is okay. Here, this is
So let's continue. So now we have our voltage. After the voltage, filtering what? Capacitor being connected. Then filtering capacitor for these two. Connected. Now the ground for the filtering capacitor for there connected. Then the next is our what? V out. So To make it neat, just do the connection, then hide the wire. You understand what I mean?
Okay.
Because of the what? Indicator.
I
Wire.
no longer using the resistor.
Yeah? We are still using the resistor. This resistor. So we just to make it instant, that's why. So let us just hide this one. Hide wire. Hide wire. These are outputs. Let's if hide the wire for the output. So this goes like this. This is the voltage output point for this one.
What's the other file one?
1K.
Flash.
Okay. Yeah, connector should be internal. Connector where I think it has to be.
This one is this net will be what? 5 volts. This look up. Oh. This voltage output here from the first voltage regulator is what? 5. This output pin. So this net will be what? 5. You can see this one is also responding because what I did here is I hide the wire. So that's so clicking on the wire or the net, it will highlight everything. So look at it now. I'll just name it what? 5 volts. You can see that 5 volts is now displaying 5 volts on this pin. Why this one is what? Ground. This is the ground. This track is the ground. So we call it what? 5 volt GND. Because we have two different outputs there. So let's name it what? If you look at some other boards, that's how they do it. But when you have different voltage level on some board, maybe you have some circuit that operate on 3 volts. There's nothing. Well, most circuit they don't work on 3 volts. They work on what? 3.3 volts. When it comes to DC, circuit, is either it is what? 3.3 volts, 5 volts, or 12 volts. So this one will be what? 5VGND. So if you click on this, it will show you what? 5 volt ground. All these ones are what? 5 volt ground. These are nets. How many nets do you have? Yeah, what's your beauty? Yeah? I think I'm putting it inside. Àfa ọmọ yìí kọ́ ọmọ oníjọ̀gbọ̀n yìí ẹjọ́ wá ó ti gbàgbé orúkọ ẹ̀ obìnrin láì rọ̀fíà.